Hello, everyone, and welcome to our first episode of Season 4 of the LIUniverse podcast. Yes, I'm Dr. Charles Liu, your host, and as always, please call me Chuck. It is always a pleasure to have our co-host, Alan Liu. Hey, Alan, how's it going?
Hey, it's going good.
All right. Run any interesting simulations lately?
This wasn't on a computer, this was mostly pen and paper, but I was working out how to create two dice that have the same probability distribution as rolling two 10-sided dice, but they're
Ooh.
not two 10-sided dice with the regular numbers. There was a math paper that I was reading about this. Apparently you can get these crazy dice, they call them.
Excellent. Well, the more crazy dice, then the more crazy games we can play, right?
Yeah, exactly.
And speaking of crazy games, we have with us today a gamer extraordinaire, plus also a historian, religious studies person, philosopher, and awesome overall pop culture meister, Hannah Liu. Hi, Hannah. Great to see you.
Hey, Dad. Good to be back.
Hey, welcome back.
It is great. All of you who have not seen Hannah before on our podcast, she and Alan, I have it on good authority from at least one of their parents, are two of the most smart alecky, know-it-all, cool, fun people to hang around with that have ever been a pair of siblings, as you might imagine.
Oh, man.
Although I wasn't sure you were talking about me at first because you started with gamer.
Oh, you've got your D&D thing. You've got your anime
6 years
thing.
of Dungeons and Dragons
That's
under
right.
my belt.
That's right.
Yeah.
So never mind, yes, that...
Well, it's relevant to the two dice conversation. Yeah.
That's right.
Two dice conversation, yeah.
I do think that would making the D100 really interesting, but that's maybe a conversation for another time.
Well, for sure.
No, it's marvelous. Yes, and we can't wait to have you give your expertise on some of the questions we have today, because we are doing a Chuck GPT. In fact, this is Chuck GPT 4, and I would love to have our producer friend, or should we call you our social media guru, Stacy Severin. Hello, Stacy.
Hi there, guys. I'm the only non-Lou. I feel like, is there some initiation I should go through?
You've been part of the team long enough.
No.
Well, if you roll two 10-sided dice.
Oh, there you go.
There we go.
You roll the right number, you're in. Right.
Yeah.
All of you out there know, of course, that I, being the host of this show, am really just the host. I'm literally talking into a microphone in front of a camera. Stacy and the other folks who are the production team, Alan, are the ones that make me and my guests like Hannah and others sound good. And there is no way that this show would exist without them. And so, Stacy, I want to thank you right now while I have the chance.
Well, thank you.
Along with
there
all
wouldn't
of our
be a
other
show
people.
without you guys either. So.
Yeah, fair.
Yeah. And you and all of our team members are so important to this project, and it's a real labor of love. And the fact that we're now in season 4 just makes me so happy.
Yeah, it's really exciting.
We are devoting today's episode to answering your questions, and we're going to play with them. We're going to talk to them. We're going to go through them. And before that, though, we're going to start with today's joyfully cool cosmic thing.
All right. Go.
I got it right this time?
You got it right this time. I was worried.
Way to start season 4 with an order correct, right?
Yeah.
This is really, really cool, everybody. In the time between the end of season 3 and now, a new mini moon has joined our solar system, or more precisely, joined the orbital region around the Earth.
Yeah.
Now, you guys all know, of course, that we have our moon, which is orbiting at a distance of about 240,000 miles, and it goes around about once every 4 weeks or so. Lovely, lovely part of our sky. But there are, of course, many, many other small objects that zip in and out around our solar system. Over billions of years, we've had certain issues. Things have hit us, right? Like, for example...
Even millions or dozens of years, depending on how big you're talking about.
Well, 65 million years ago, of course, we had a big thing hit us,
Yeah.
and it probably led to the demise of the dinosaurs. Yeah, but this time, this little visitor is just coming to say hello briefly. It is being captured by the combined gravity of Earth and the moon, and for about 2 months, it's going to make a small partial orbit around our Earth Moon system and
Mhm.
then head along in its
Yeah.
merry way. So, this
Very
object,
exciting.
yes, it has been named 2024 PT5,
Yeah,
and the
2024 for the year.
mhm. And the article that announced this discovery, which was published in the research notes of the American Astronomical Society, has been downloaded more than 100,000 times. Uh,
That's awesome.
Very, very exciting. Everybody's paying attention. You won't be able to see it, unfortunately, without sophisticated telescopes, but it's still a fun thing to do.
Well, the thing's only the size of like a school bus, right?
Yes, but a magic school bus, perhaps. Me,
Even better than a
me.
regular school bus.
Yes.
Seatbelt, everyone.
Yes, love that show. Hannah, little tiny things coming around the Earth are part of like mythology, part of history, part of humanity, is it not? I mean, what does it mean to us as a species that we, for a moment, have this little moon coming by?
Well, first of all, I'm very sad you can't see this with your naked eye. I really want to see it.
Yeah, it
I'll have
would
to
be
look
cool.
up some pictures. Well, honestly, as you were talking, this reminded me the most of Caesar's Comet. It goes by a lot of different
Oh,
names. I'm sure there's a real astronomical name for it that I don't know,
I can take a look.
but it's this comet that appeared for something like a week.
oh,
Yeah.
So a very short period of time in the summer in 44 BC. And we have attestations both from the Romans and also from some Chinese sources that make us think that maybe this is like a true thing that happened.
wow.
And the interpretations of this very brief visit were extremely significant for the Romans, who Caesar had just been assassinated, and his adoptive son is going around trying to avenge his death, and
Hmm.
literally printing coins with the comet on the coin to represent the deification of his father. I mean, it
Dang.
was like a huge deal. It was like in poetry, in Roman poetry, it was in Roman histories. And it was just there for 7 days.
Yeah. Yeah. So I
Wow.
was looking this up. The astronomical designation is just like Comet -43 because it's 44 BC, which is -43 because there's no
Oh,
year
sure.
zero.
Okay.
So
Yeah. Mhm.
not a very
Mhm.
creative name, just like C for comet, the year, and roughly when it happened in the year. So C -43 K1.
Oh my goodness.
So for
Great.
instance,
So
there's a
what I'm
comet.
talking about
Yeah.
is Comet C -43 K1.
Yeah.
We can pretend that I said
Yeah,
that.
there's been a
Sure.
in the news lately. See 2023 A3. I want to say, yeah, because again, it's kind of discovered in 2023, and A3 represents the part of the year that it was discovered.
That's
So
marvelous.
yeah,
So, Stacy, being our social media guru, what do you think would have happened if in 44 BC there was Facebook or,
Ugh,
TikTok or whatever, and there goes our Caesar,
oh
right?
no,
And here comes this comet. I mean, what would have happened?
well, first of all, their social media person would have had a lot of trouble hashtagging a -44.
for sure, yeah.
Hmm.
You know?
Glad we don't have negative years these days.
I mean, you would have those people who would grab their stone smartphones and
Their tablets.
their tablets. That's
They
right.
did
They
have
had
tablets. They were
tablets.
stone, but,
They
they're
had
tablets.
tablets. I think the social media might have been a little helpful because otherwise they might not have known what they were looking at, just as people would get so confused with an eclipse or something like that,
True, yeah.
thinking that the world was coming to an end. So I kind of think it might have been a good thing.
Probably, yeah. I mean, comets,
Probably.
we've known the explanation for like less long than eclipses. I know that
That's right.
like the Babylonians were tracking eclipses. I don't know how much of that data got into any other civilization directly, but they'd been tracking eclipses for a long time. The Mayans had their things too. But comets, like there was in 1680, there was a big comet and it disappeared, and then another comet another comet in air quotes a few weeks later showed up, and it was right then in 1680 was the first time someone was like, hey, you think that comet from a few weeks ago and the comet from now are like the same comet, just like came back? Because they didn't know if it was part of the astronomy realm or if it was part of like the atmosphere, or they didn't know what it was, but that was sort of the thing that right as the time Newton was making up his laws of motion and figuring out how those worked, it was really connected to all of that scientific inquiry going on at the time.
I love it. It's marvelous. And scientific inquiry is where we are going now, because we're going to answer questions for this episode of Chuck GPT. Chuck GPT 4 to be precise. And Alan, we are not 4.0, are we? We're 4.0.
Yeah,
and
yeah.
That's
Chat
important.
GPT was 4.0 with the letter O because I don't know, man. OpenAI likes the letter O because it starts their company name or something.
Wow.
They're like, nah, letter O, not number 0. But we'll probably stick with the number 0 in the episode title. I guess you can see how that shakes out.
I think that should work out well. And we are going to have a question, at least one. I took a look at the sheet of thinking about intelligence out in the cosmos.
Yeah.
So let's get that ready to go. But please bring on the questions. Alan, go ahead. And Stacy, I know you're going to bring a question on as well in a little bit. But let's go with the first question, Alan, from our audience.
Okay, we're just going to start with the first one on the sheet here, and that is from NSimplexPachinko, who is asking, during the condensation of matter around 300,000 years after the Big Bang, did space-time stop expanding, or did it continue expanding as the energy within it was happening there?
Good question. And the answer is yes, space was still expanding. In fact, space still is expanding today, right? The Big Bang itself marked the beginning of expansion of space. There was a brief period of time, we think, right around the Big Bang, which we refer to as inflation, right? Not to be confused with the price of bread. But we have inflation, which ballooned space-time as a sudden and huge expansion. And then after that, went back to its normal, regular expansion. And everything that has happened since then has been in the context of that expansion since then. So your question, Pachinko Meister, about 300,000 years ago, when there was
after
that,
the Big Bang.
Yes, 300,000 years roughly after the Big Bang was the time when matter and energy were able to stream separately. They were no longer tied together, and this is called decoupling. And when that happened, then matter started being able to coalesce into objects like black holes and stars and galaxies and things like that. The energy continued to expand within the universe as it expanded. So the background temperature of the universe started going down. 300,000 years after the Big Bang, the universe was about 3,000 degrees Fahrenheit. And now it's about 3 degrees.
So the idea here is it's sort of like the same principle that you talk about, like the ideal gas law that you might have heard of in chemistry class, or the way that your refrigerator works, right? Where like, but when a gas expands, it cools down. And so the gases and plasmas in the universe, as they're being able to spread out more because the universe is giving them more space, they're cooling down, and that's causing all these things. So they're actually like directly connected.
Makes sense to me. Yeah, that's what I teach my intro astronomy class folks. Yeah, just imagine the thing getting bigger. You got the same amount of energy filling the space, so the temperature is going down.
Yeah, I know we've talked in other episodes about dark energy, where like the expansion rate of the universe has been speeding up. Yes. It was really fast at the beginning, and then like slowed down, but didn't go to 0, and now it's speeding up again.
The inflationary moment was just a blip. So the expansion rate had been slowly going down, as you would expect. Gently going down after that inflationary blip. So you got expansion and then big inflation, and then it comes back down. That's actually what the sound it made, by the way. Big inflation.
Yeah, scientifically, that's
I'm just imagining a dinner table with all these loose.
They're crazy.
That's how it goes. Yeah.
How it goes.
Right. And then it has been slowing down, but the slowdown is very gentle. The expansion rate is still almost exactly what it was after inflation ended. But then the expansion's increasing speed also, it's very gentle. It's subtle. It isn't this gigantic fast speed change, but it definitely is changing, and we think it is because of this thing called dark energy. But
All right.
that is a question for another time. Yes,
Okay.
absolutely. Thank you. Thank you, Pachinko Meister, for that question. All right, next question.
Okay, we have a question all the way from a listener in Poland.
Exciting.
Yes,
Yes, I
Poland,
Whoa.
have been
home.
speaking to Shemo Zambora on social media,
Ah,
and Shemo has the following question.
mm-hmm.
Okay, the volume/length of space should be different for every observer depending on how fast they're traveling or how strong the gravity field is. In other words,
Mm-hmm.
the speed of light will always be constant for each observer, but it may have a different value than 300,000 kilometers per second. Distances on cosmic scales may vary due to your speed. When you're traveling faster in space, your distance should be shorter. What am I missing? Those are Shemo's words.
What a great question, Shemo. You're not missing anything. You have exactly described the insight that today we call the Lorentz contraction,
Mhm.
which actually Albert Einstein built into his special theory of relativity. And you're absolutely right, let me just say. Indeed, because there's something called index of refraction, the substances, the media that light travels through will cause light to slow down as it goes through them.
Mhm.
Through space, right, through perfect vacuum, the speed of light is indeed almost exactly 300,000 kilometers per second. Actually, 299,792.458 kilometers per second.
We use it to define the meter, so it's an
Yeah,
exact number.
it's an exact
Wow.
number. Yeah.
Off the dome.
Whoa.
Yes.
Yeah.
So that's it's just a thing. We all know it now. And as you go through things like air or water or diamond, the speed does slow down of a beam of light. But no matter who's seeing it, it winds up looking the same. As a result, and Alan, you can take it from here,
Mhm.
we get the Lorentz contraction.
Yeah, so the Lorentz contraction is pretty much just like you described. As you move faster in one direction, because it's sort of like the opposite of time dilation. So you might have heard of the twin paradox, where if you have a twin, like twins that are born at like the same time, and you put one of them on a really fast spaceship that goes off to Alpha Centauri and back, then the twin that moved will have aged less than the twin that sort of stayed in one place.
Yeah.
Um,
Yeah.
but so because the speed of light has to be constant for every observer, the result is that when you are that moving twin, when you're moving really quickly through space, you see yourself as going through regular time, but you see the distances along the axis of your motion as getting contracted. So we see this with, I mentioned this before in the podcast, there's an unstable particle called a muon that gets produced
Mhm.
by cosmic rays in the upper atmosphere of Earth or in supernovas and stuff like that. And muons from Earth's atmosphere, like where the cosmic rays hit the atmosphere, we see more of them on the ground than we would if we didn't have these relativistic effects. So because they decay
Mhm.
so quickly, we'd only see very few of them on the ground. But from our perspective, the muons are experiencing time more slowly, so more of them get to the ground.
Yeah.
And from the muons' perspective, the Earth's atmosphere is thinner, and so more of them get to the ground than you'd expect.
It's pretty cool, and it's amazing
It's
that this actually
wild,
been
yeah.
confirmed. Now,
Yeah, we can measure it. It's crazy.
Hannah, imagine you had traveled in that way,
Oh
and you come
no.
back, and you're younger than Alan. What would happen to our family dynamic?
No, no,
Oh
no.
my
That's not
goodness!
how it works. The oldest sister is always the oldest and always the tallest. It doesn't matter
Oh, that's
how
right.
tall
You're
you are.
Yeah,
yeah,
sure. So
Alan.
maybe I have to be moving close to the speed of light upward and downwards so that contracts me, and that's why you think I'm shorter.
That's probably what it is.
Yeah.
Yeah, you're just getting a little
Yeah.
contracted to my eyes,
Yeah, for sure. Yeah. Gravity can do a similar thing. It's gravitational time dilation and gravitational effects to space, and it's really whack.
Yeah.
The other thing I want to say is talking about light being slowed down through certain mediums or media. There are actually some really weird, really cold quantum stuff like Bose-Einstein condensates where you can slow
Mhm.
light down to like walking speed. It's kind of
Or
crazy.
yes,
Or
or even for a fraction of a second, stop their forward motion completely.
yeah, so you
The
can
fo-
there
Whoa.
it's crazy. You can just like be like, yeah, there's light just hanging out in this really cold atomic thingy. It's
yeah.
weird.
It's not like it's stopped by a wall or a mirror. It's like it's just sitting there waiting to keep moving, which is really quite remarkable. I think that's marvelous. So, thank you, Shemo, for your wonderful question. Stacy, thank you for helping us cultivate such wonderful friends from all around the world, including Poland,
Definitely.
homeland of Marie Curie, homeland
Right.
of
Yeah.
Frederick Chopin,
Lots of good
all
people.
kinds of wonderful stuff.
And the Wieliczka salt mines, which I have licked.
Oh my gosh!
Whoa.
Wait, what is this? What is
Can we
this,
see
Hannah?
your tongue?
I'm cool. I'm good. So far, so good.
Wait. What are these? What are these mines? I remember that you did travel to Poland at one point a few years back. Okay, what is this thing?
Yeah, I had the chance to go to Poland, and I was in Wieliczka, I think is where the salt mines are.
Mhm.
It's called the Wieliczka salt mine, and it's this incredible site. It's like historical site, but it's also art, and the salt miners, once they mined out a bunch of salt, also made these incredible sculptural pieces. There's a
Ooh,
whole church down there.
wow!
It's really cool. You think you're going to get a mine tour and you get that, but then you also see these like scenes made of dudes made of salt. It's very
Wow!
biblical.
Wow.
But I was very curious about if it would taste salty, and it does.
now, now, was Lot's wife actually a scene down there?
I,
'Cause
I don't recall, but I really hope so.
Yeah, one hopes
those
so.
those of you who don't know your Old Testament, Lot's wife looked back at the destruction of the city of Sodom and Gomorrah. Well, I can't remember which city it was,
Yeah,
but
Yeah,
it
one of
was.
those.
and one of those, and was turned into a pillar of salt. Yeah, which is really quite amazing.
Kind of whack.
But the other question I have, though, Hannah, is did you have to sneak a lick or did you just openly lick it? Because I imagine if every tourist were to lick the thing, sooner or later, all you'd have is like formless, gross saliva on the thing.
You don't look at the statues. You look at different.
No, I
parts
didn't
of
lick the
mine.
statue. I didn't lick the statues.
Okay,
Those are
okay.
you can't get to those. They're behind fences, and I wouldn't
Okay.
want to accidentally destroy anything. But I did lick the wall, and there's people milling around. I don't think anyone saw me.
Oh my God.
Okay.
Now, do the statues withstand the rain okay?
They're
It's
deep
all
underground.
underground, so there is
Ah.
no rain. Yeah, it's
That's
genius.
great.
Honestly, it's very interesting.
That's really cool.
I love that. Wonderful. Okay, next question.
All right, so we're gonna get a question from a Astronomy 100 student, which is one of your students this time.
Ah,
This one is Earth intelligent?
yes.
We're talking about AI, now we're talking
Yes.
about GeoI.
Well, yeah,
Yeah.
Earth Eye. There has always been this sort of Gaia hypothesis that Earth is somehow an organism, and we just happen to be on it in the same way that, like, there are bacteria in our guts, right?
Yeah.
And that there's this organism, and we're there, and that can either be a good thing or a bad thing, right? Either
Yeah.
the Earth wants to get rid of us because we are a contaminant, or
Yeah.
Earth wants to nurture us because we are its progeny. But this intelligent question, I think, goes even further to sort of what intelligence actually is and AI is, right? And as Chuck GPT-4, I think it would be appropriate for us to ask that action first. Hannah, let's have you go first, okay? Is Earth intelligent?
Is Earth intelligent? Well, I think depending on who you asked and what they studied, they might have a different answer. I think it would be really interesting to ask a biologist. You mentioned the Gaia hypothesis, which is
Right.
can be very controversial among
yeah.
biologists.
Yes.
It's not
for sure.
remotely settled or anything like that, right?
Yeah. There's some really interesting thoughts on what parts of that might be true. The idea of like homeostasis. Is it is the Earth just trying to maintain sort of biological balance, or is there more to it than that? Which, of course, the Gaia hypothesis, the name of it comes from the Greek goddess, so to speak, or
Right.
being, Gaia, which is a being that's attested as sort of a mother, an earth mother, a mother of earth, mother nature, kind of being more than 3,000 years ago is when we first encounter, at
Wow.
least to our knowledge. It might be even older, right?
That's like the old Greeks.
Yeah, it's like linear B script.
Yeah, like the
We
Minoans and
find
Messenian type people.
Whoa.
Yeah, totally,
Dang.
totally. It's
Okay.
yeah.
Like before Odysseus.
Yes, before Odysseus, before Troy, as much as
Wow.
that was true.
Pretty amazing.
Yeah.
And then, of course, there's Gaia, who shows up in the 20th century in Percy Jackson.
Yeah, well,
Yeah.
Right?
Yes,
directly related.
My Percy Jackson collection, right
Hey,
behind
hey,
me.
hey! Yes, right. But in that
Yeah.
case, the Gaia was a pretty scary individual, right? If
Well,
you
she's
awaken Gaia,
scary.
then she would like wipe you out.
She's scary. She's the mother of incredible chthonic beasts in Percy Jackson and in Greek mythology. Earthquakes are terrifying if you don't know what's going on. So those are the purview of Poseidon and a lot of later mythology. The
Right.
ocean god, the earthquakes come from the ocean. You can think about tsunamis coming out of the water in a really scary kind of way.
Okay, so but from that point of view, Earth could well be intelligent from that aspect, because humans anthropomorphized the Earth to some extent, right?
Yeah, and interestingly, she's married to the sky. The Earth and the sky are sort of in this eternal partnership. In Greek mythology and Egyptian mythology, one feeds the other, and they have kids together.
Yeah.
Dang, sounds pretty darn cosmological.
Yeah.
All right, Alan, I know that you are an expert on artificial intelligence.
Yeah.
So tell us what you think. Is Earth intelligence some sort of AI, or is it like non-AI? Is it the ultimate natural, non-artificial intelligence?
Yeah, well, if the Earth is, as we believe, created by natural forces, then it's not really artificial intelligence. So the A part, it's not an A, but the intelligence part is more interesting. There's a concept in AI about like there's questions in AI about the philosophy and the practicality of what it means for something to be intelligent. So there's a few ideas there. One is the idea of how much computational power something can have. So how much it can synthesize data and turn it into something new. There's also ideas of agency. So does it work to achieve a goal, right? So the idea of humans, we both are really good at taking in lots of information and making decisions, and we're also good at taking these goals and finding the steps to achieve them and making that happen. But if you think about something like a thermostat, even that has some level of agency, right? A thermostat has a goal of setting the room to a certain temperature, and it can take steps to achieve that goal of turning your furnace on or turning your air conditioner on, and then it achieves that goal. So the question is, does Earth have goals, and does it achieve it? If you want to talk about the agency end of things. And I'd say that it's kind of hard for us to tell if Earth has goals. We don't have like exact things that Earth does that sort of indicate to us that it has some broader purpose. But on the other hand, it's like a lot of things like thermostats exist, and things like the carbon cycle, like the nitrogen cycle and stuff like that. There are these things that sort of want to come back into balance, want in the sense that they tend to do so over time. So I would say that Earth is definitely smarter than a thermostat. And I'd say it's more complex of a system than a thermostat, but whether it has intelligence the same way that a human does, or even like a lab mouse does, I'd say that we don't have the time scales to look for that for sure, but it might not,
Okay. All right. So now, Stacy, having heard the expert opinions of Hannah and Alan,
kind of expert, at least.
You're very humble, but you know a lot.
I do.
Okay.
Yeah.
Stacy, what's your opinion?
My opinion, I'm coming from a different angle on this.
Yeah.
And I have the music degree, right? Not the science degree. So, but this is kind of what I'm thinking. The Earth is going to do what the Earth is going to do. I think the Earth has its thing, and its things it does, and its rhythm, and its whole thing, and we're there, but I don't believe we can really control it. And I think we're seeing a lot of that with weather patterns and all kinds of things. Had we listened to the scientists in the 70s and maybe done what they said, then maybe it wouldn't be the way it is now.
Made the Kyoto Protocol happen, kind of.
But I think about this when I hear about these terrible things that are happening frequently now, like floods and fires. Every year,
Mhm.
there are
Mhm.
regions where homes get wiped out with wildfires. Well, maybe they shouldn't have built homes there. But I,
Mhm.
I just
Mhm.
wonder, if we're just not tempting it to wipe us away because we're doing stupid things.
Yeah, I feel like to some extent that's like if you have a jellyfish around you and you stick your hand in the middle of the jellyfish tentacles and you get stung,
Ouch.
it's like it's like you could argue that's because you annoyed the jellyfish and the jellyfish took revenge on you, or you could argue that it was just going to happen. They don't have brains; they
Mm,
just have nerves, right? But
Mhm.
it's
hmm
still you messed up.
Yeah.
So
Yeah.
whether I don't I don't think we have enough evidence right now to say that to support the idea that the Earth is taking revenge on us for messing it up. I think that we need to see new things that we haven't seen for us to actually think that's true, rather than to just assume that it's not true or based on like null hypothesis type stuff.
I
But
think
it
that's
doesn't really
really,
matter, right? It doesn't matter if it's trying to take revenge on us or if we just
yeah.
messed it up and it's naturally messing us up in return.
I think that's really interesting in the context of sort of this Greek mythology that we're talking about too, because we talked a lot about Gaia, and she sort of has these horrible monsters that come and get you, and the Earth is really scary,
Yeah.
but it's also the only place that's safe, right? Because the
Right.
ocean is
Yeah.
even more scary.
Ooh.
But
And
then
space,
later, if you
man.
sort of move later in Greek mythology, like closer to the modern period of
Yeah.
time, you get a new Earth goddess, which is Demeter or Demeter, often as she's called in
Oh.
English. Yeah, and
Yeah.
she operates much more in mythology by choice. She makes things happen to people because she's mad
Hmm.
or
Wow.
because she's happy. For example, winter comes because she's upset that her daughter has been stolen away by Hades. That's
Persephone.
the Hades
Right.
and Persephone thing.
Yeah. Yeah.
Or maybe she makes winter happen because she's distracted looking for her daughter, and it's kind of just like that's what happened. She's got other stuff to do.
Yeah.
But either way, she has a little bit more agency, and that's sort of a later
Mm.
idea that comes about, is the Earth just kind of a scary thing that we should do our best to kind of make happy and take care of and hope she takes care of us? Or is this a thing where we can do specific things to make the Earth happy so that we don't freeze to death in the winter or
Yeah.
get our houses burned down by wildfires? And maybe those specific things involve certain climate agreements and things like
Yeah.
that.
Yeah. Yeah.
Okay.
Yeah.
Well, so maybe the ultimate answer. Uh, we know that there are parts of Earth, oh, at least one species that thinks it's intelligent here on Earth. Maybe we
Yeah.
should use that intelligence to be better denizens of the Earth than we might
Oh,
currently
definitely.
otherwise
Yeah.
think.
I feel like it's almost like there's a philosophy question and there's like a hypothetical question about is the Earth intelligent? But in the practical sense, we got to take
I
care of
love
it
it.
either way.
Yeah. All right. Thank you. Next question.
All right. This question comes from someone who has the interesting name on social media of I have an unoriginal name.
How original.
Yeah, it seems pretty
Exactly.
original,
Seems pretty
actually.
original, actually. Yeah, it's a little bit of a paradox there.
As someone
This
whose name is Hannah, I get it.
Well, at least you got the palindrome going on. It's that same backwards and
Yeah.
forwards. That's pretty fun.
Well, people, when they ask me if it's Hannah with an H, I say it's two H's, and then they get confused and upset.
Well, it's like how ChatGPT only recently learned that strawberry has 3 R's in it.
Yeah, I heard about that.
Oh, really?
Yeah, apparently the previous version of ChatGPT thought there were 2 R's. Maybe something to do with the way its words are broken up in its internal memory, or just it was dumb, one or the other. But now, if you ask it how many R's is strawberry, it says it has 3 R's. But if you ask if it 9.11 or 9.8 is bigger, it still gets that wrong. It says 9.11 is bigger.
Whoa. So a warning to all of you who are doing your homework with AI, go ahead and do it, but just make sure that you know whether it's right or
And
wrong.
make sure Alan isn't your math teacher because he'll know you cheated.
I mean, it's not even about cheating, it's about getting it wrong.
That's right.
Be better than ChatGPT. Be better.
That's right. And I think, since we've brought it up, I think this question of cheating is the key point, right? we think, well, you're breaking the rules if you're using the technology. And of course, if that's the rule of a test or a
Yeah,
class,
you
fine,
shouldn't.
don't break the rule.
Yeah, yeah,
But in life, right, it's a tool just like anything else, whether it's a calculator or a car or
yeah.
ChatGPT, which is a piece of software on a computer, right? If you're going to use it, but use it wisely. Be better than it, right? And that makes it so that whether or not it's cheating, you are benefiting from it instead of
Yes.
suffering from
Don't cheat on your tests, but in life, it's a tool that you can use. That's a good message.
We weren't allowed to use calculators in my day.
it.
Dang.
Yeah.
Jeez, Stacy, boy, when was
It's
that?
when they were called four-function
Jeez.
calculators.
Wow.
It was the
We had
four-function
four functions.
calculator. It had red numbers,
Oh,
and
wow.
it clicked
Yeah,
when
we
you
had.
clicked a button. It made a sound.
I had those still. Well, to be fair, they
Yeah.
made us use TI-84s like 2 decades after they were obsolete. So
Well,
Unbelievable.
the big thing was the kids would type 7734 and turn the display upside down,
oh yeah.
and it would look like it's an HELL.
Oh boy. Oh man.
I'm like doing that in my head. I'm like flipping it backwards. Like,
Well, if you put a
oh.
0 at the beginning, it's a little bit nicer. Very exciting stuff about calculators. Always want to talk about calculators, but we have a question.
Okay.
The questions, so first they say, thank goodness you have a channel. Very nice of them. The question is,
Aw.
yeah, they said more nice things about the show. They say everything you've ever said has had me on the edge of my seat. It's been a pleasure to speak, interact with these wonderful people, and they can't wait for more videos. Yeah, that's how you get your question asked on the show. No, it's very nice. We appreciate you too.
Just start your
Yes.
question by asking ChatGPT to say some nice things.
All right. So the real question part of the question goes like this. How does the cyclic model of the universe deal with information not being destroyed?
Whoa. Well, unoriginal Meister, that is actually not a very original question. Although it
It's a
does
very
have,
interesting question for
yes,
sure.
it's a very interesting question. And that's why people have been asking that for a long, long time. And even questioning the whole concept of the cyclical universe to begin with. Let me just give a quick sort of framing of that question and a quick answer, but then I want to throw it to our experts here today to give more commentary on this. If you have a cyclic universe in modern physics, the idea is that instead of just having a big bang that has happened in the past and just keeps going and going and going, there will actually be a mechanism built into the universe that it will come back together in kind of a big crunch or a big collapse, and then do it again and again and again, following some sort of mathematical or physical reason. But we also know that in the thermodynamic part of physics, and the information theory side of physics, that once you have information and stuff out in the universe, you can't get rid of it completely. You can reorganize it, you can repackage it, but you can't destroy it without some fundamental violations of physics as we understand them.
Yeah.
So your question about cyclic universe basically must require some sort of physics that is beyond what we normally think of in information theory or thermodynamics, that this information can be stored somehow. There are mathematical ways to do that, but we haven't been able to confirm any of them yet. Alan, as our mathematician,
Yeah.
I want you to give you some sense. How can you put an infinite number of things into something that is finite in some extent or another?
Oh man, well, there's a whole lot to that. So one idea that you can think of is they sort of call this like analog hypercomputation.
Oh,
It's a very fun name. It's two
sounds
ideas.
pretty simple, honestly.
that just like got me right in the gut there. Holy
Yeah.
moly!
Yeah, hypercomputation is an idea that you can do things that are beyond the realm of ordinary computers. And analog computation is when you use like a physical quantity to represent another physical quantity, like an electric current to represent the flow of water or something like that.
Gee.
And there's an idea that if you imagine it's like a number like pi, right? It has an infinite number of digits that go off to the right of the decimal place forever. But it's still only one number. So there's some sense in which pi is a single number that has encoded an infinite amount of information of digits.
Ooh.
So if you can have something in the universe that's so precise that you can tell the difference between pi up to 1 trillion digits and pi up to 1 trillion and 1 digits, then you can store 1 trillion numbers in a single number.
Wow.
So It's
Wow.
possible, and you don't know if this is actually the way the real universe works because we haven't been able to test anything close to that scale yet. But it's possible, like as we were talking in the Katie Mack episode, that there are certain physical constants that might go from one cycle of the universe to the next cycle
Right.
of the universe.
The rest of our audience, Katie Mack was our guest in the finales of season 3. She is a cosmologist, astrophysicist, wonderful, wonderful guest. We were really glad to have her. Yes,
Very cool
Katie.
episodes. You should watch them.
Thank you, Hannah.
Thanks. Yeah.
I mean,
So
Katie Mack is awesome. You're fine. Katie Mack is awesome.
Yes, I agree with you 100%.
Yeah, definitely. Yeah, so I don't know if the physicists have anything to say about whether this is the way information gets from one cycle of the universe to the next, but at least
Mhm.
mathematically, if you could
Right.
have some ultra precision on the values of those physical constants, you could send all the information from one universe into the next universe in theory that way.
Yeah. Wow. Well, so Hannah, cyclic universe from a philosophical, religious point of view. I mean, the universe that's recreated in certain texts, right, and contexts from ancient history. But then, does it come back? Does that information get destroyed, or does it live?
I mean, that's also a great question. When you started talking, Alan, I was thinking about cycles of birth and rebirth and kind of multiple religious contexts. And now I'm thinking about archaeology and how we preserve information through the
Yeah.
many centuries. And, technology has been really evolved as well. Technology meaning, glass blowing to
Yeah.
this what'd you call it? Analog hypercomputing?
Hypercomputation, yeah. We have not been able to make that happen on our computers because we are limited by the physics of silicon, alas. But
So theoretical then, but
yeah. It's an idea that people have brought up mathematically and described how it could work if we had arbitrary amounts of computer power.
Yeah. I mean, that's so interesting. And I remember hearing way back years ago that someone important, some government was looking to preserve some information, and they asked some archaeologists of what are the best ways that things get preserved over time. Anyway, we're important. That's all I'm saying. But but back to what I was originally thinking about sort of cyclic models of the universe.
Yeah.
I started thinking a lot about the cycle of samsara, which is
Hmm.
a cycle in a lot of Indian religions
Oh.
from the Indian subcontinent. I learned about it in the context of Hinduism and Buddhism, but it's certainly
Uh-huh.
part of
Okay,
the
yeah.
tradition of Sikhism and Jainism or Jainism. I hope I'm saying that right.
Mhm.
And the idea that you get born into this life, you live your life, and then you die, and then you get reborn, and you don't
Right.
necessarily recall where you've been.
Yeah.
And so actually that information, you don't have access to it anymore, but it doesn't die. It's out there,
Mhm,
Yeah.
mhm.
and then ultimately the goal is to exit actually this cyclic model where you kind of reach what some might call nirvana. That's sort of a Buddhist word for it. But there's other sort of
Wow.
conceptions of this idea of liberation from this cycle, where are actually in a lot of cases interpreted as gaining insight, sort of gaining knowledge.
Mhm, mhm.
Although in some cases it's also interpreted as losing knowledge or losing your connection with the earth and where you've been, and sort of
Yeah.
just
Yeah.
going off on your merry way. So it's really interesting of
Yeah.
how does information get sort of passed along in these cycles or not.
Right.
Yeah.
And there's a Jewish idea in Jewish mythology
Mhm.
where time is a spiral. So,
Okay.
we have
Oh.
the same events every year, the same holidays, the same uh, birthdays, right? All those things.
Mhm,
But they're
mhm.
slightly different each time, right? Time
Mm.
marches on,
So imagine
connecting
a
us to the
spring
past.
going this way.
Yeah, exactly, like a slinky, right?
Oh yeah,
Uh-huh,
time is a
uh-huh.
slinky.
Yeah, time is a
That's actually
slinky,
a
and
pretty insightful way of thinking about it.
Yeah,
I
right.
think
I
it's
love
cool.
that.
I kind of like it. You get to do the
Mm.
same stuff, but a little different each time. There's
Slinky
something there.
cosmology. I like it.
Yeah.
But this really brings up the question: what are the best ways to store things permanently? Like, how long can you actually preserve information? We know that time marches on. Soon, well, not super soon, but like billions of years from now, the sun will go red giant and our solar system will be thrown
Mm.
around in the collision between the Milky Way and Andromeda galaxy. Like, how do we just keep stuff around even for a few hundred or a few thousand years, right? Do we carve it in stone? Do we drop it into a salt mine? I mean,
Or
what are we going to
permafrost,
do?
yeah.
Yeah.
Just be careful no one starts licking it.
Yeah. I was reading a news article that the seed vault that they've got in Svalbard that is
Yeah.
Oh,
buried
yeah.
into the permafrost, like they've had problems with like just really heavy rain and snowmelt just getting
Oh
into the seed
no.
vault.
Oh
And
no.
so I mean, it's still serving. People talk about it as though it's like only there for the apocalypse to like restart civilization, but like the other job that it has sort of in the short term is if there's a local disaster at one seed vault somewhere else in the world, they have a backup copy of those seeds.
Right.
So that happened like during the Syrian civil war. A lot of the
Wow.
seed banks
Mm.
there got destroyed, so they had the backups at Svalbard, and so they could
Wow.
restart
Mm.
those seed banks. So in the short term, it's still doing its job, even if it gets flooded every so often.
All right.
But in the long apocalypse type scale, it might not do its job as well as people were hoping.
Sounds like the answer is make lots of copies. Make lots of copies. I can do that. Okay.
Definitely make lots of copies and maybe store them in an oxygen-free environment.
At the bottom of a bog.
Archaeologically, I mean, that's the peat bogs. The stuff survives in there because it's a less oxygenated desert,
okay,
pyramid,
okay.
same deal.
Yeah.
Space might be pretty good for that. Is all I'm
mm,
saying.
mm.
That's true.
Yeah.
I've heard ideas that like our moon landing sites might be the last archaeological remnants of our civilization, depending on how things go.
Ooh. We should start
Wow.
putting stuff up there.
That's
maybe.
profound.
Uh-oh.
Yeah.
But in the TV show Space 1999, humans put so much nuclear waste on the moon that it was blasted out of its orbit.
That's
And-
not how it
Okay, not
would
nuclear
happen.
waste.
Nuclear waste, they promise to get rid of it, not keep it around.
Yeah.
Yeah.
Or reuse
Okay.
it.
Or reuse it.
We
Yeah,
could
there
use-
are ways to recycle nuclear waste that people
Yes.
are working on. It's really cool.
I hope that all works out very well. Yes, to be discussed for the future. All right, I think we have time for one more question. Stacy, tell us, what is the last question?
Okay, we have a question from Andy Love. Love that name. Andy says, "Hi, Chuck. I hope it's okay to call you that.
Yes.
I wondered if you or Alan could tell me your thoughts.
Oh, okay.
I have wondered about the quantum gravity issue. My thought
Okay.
is that gravity is emergent from loop or string vibrations, where the outward pulse of the loop or string creates the atoms (parentheses Higgs field), and the inward pulse is gravitational force, meaning there is no need for a new quantum gravity theory. Gravity is already quantum. Thanks in advance for your time, and thanks for your LIUniverse show."
Oh, man.
Wow, wonderful question. Thank you, Andy, for this. I love this question. Here's the story. Oh, you finally got that. Okay, thanks, Anna. I appreciate
Took me
that.
a second.
Okay.
I got it.
Okay,
I feel like we can't make the same joke too many times. But we can.
that's true. Well,
I don't know. We've done a few of them a lot.
Just watch me.
It's a
All
very
right.
special name.
Let's
I
go.
like. Yeah. Okay, Andy, your comments about quantum gravity are indeed one way to interpret it. Now, I don't do research in quantum gravity, so I've read up on it, but I'm not exactly like a specialist in it. So we will try to find a specialist sometime as a guest for this coming season so we can answer that question as precisely as possible. But yes, your basic idea that if string theory is correct, or some version of string theory is correct, and you imagine that the way that the strings on the quantum level vibrate, and in one case it might produce one kind of particle, and in another case it might produce some other kind of particle, maybe not just in out, but depending on the multidimensional vibrations, it is very possible that one kind of vibration produces the kinds of particles you were describing that have mass, right? Things like quarks and leptons and things like that. Or the other direction, or other kinds of vibrational modes, may lead to something like a graviton, which is probably massless and probably, if it is correct, has the properties that carry gravity from one place to
Are
another.
gravitons supposed to be massless?
Well, that's the thing. We think we now have an upper bound on how massive they are because of
Okay.
the uh, explosions that we detected using LIGO, right? The gravitational waves and so forth.
Yeah.
But but if you are thinking of cosmology with quantum gravity or quantum loop gravity as part of it, then you
Yeah.
can literally assume that space and time arise from quantum itself. That you don't actually have what Albert Einstein showed, general relativity as space-time being this sort of fabric in which objects exist, but rather the fact that objects exist create space-time. And so now we have to have that boundary. Where is it that what we see today, that space-time does exist at our classical level, right? Where does it interact with the quantum level, where space-time doesn't really exist until it gets big enough that it interacts with all of us and all the other particles around? So you're changing cosmology completely on this question. So whether it's emergent or not remains an issue which we don't know about, and it brings up right in Hannah, I just have to keep asking you about this universe thing, right? The origins of the universe. We scientists, we're pretty sure we know what happens after the universe is created, but we still don't really know how the universe is created. And I know we've been thinking about it for a long time. You
Yeah.
have knowledge about sort of the human endeavor to understand the origins of everything, whether it's cyclical, whether it's one time only. I mean, what do you got for us?
Unfortunately, not much. The ancients couldn't figure it out either.
Yeah.
Darn.
I
I
know.
imagine every person you ask would have a different answer, you know?
Yeah, pretty much every person you ask have a different answer, or at least every civilization we have record of, you know. But a lot of
Yeah.
civilizations also have a similar idea that, as far as I understand, astrophysics does today, of like stuff came from nothing. First there was nothing, and then there was stuff.
Mhm.
Yeah.
Or in some cases, at first there was chaos, and then there was order.
Ah.
So unfortunately there's not a lot of people who really found an answer to where did the chaos come from, or where did the nothing come from.
Mhm, mhm.
Yeah.
You know, going back to the Greeks, because that is my area of expertise. I know I've talked about it a lot today, but you know, they started with chaos, right?
Mhm.
Yeah.
And then Gaia, among others, came and created order of the chaos, and here we are today. But you know, I don't think I've ever really encountered someone who was like, what came before the chaos, or where did the chaos come from? Because it's so
Yeah.
complicated.
Right. Yeah. It reminds me of sort of math that we had this discussion. I was talking with some people that I was working with um about like there's and this goes to some philosophy and some religious studies things too. The idea is there necessarily a first cause from which all other causes flow?
Oh.
And if you're a mathematician, you can sort of think about this a couple ways. Like there could be a first cause from which other causes flow. There could be circular reasoning when it comes to causes that like there's no single first beginning to the line because something causes A causes B causes C causes A somehow
Mhm.
mysteriously. Or you could have like the way we think the universe might go on forever in both directions of space, you know, to your left, to your right, to your up, to your down, to your forward, backward. It's possible that the causal history of the universe, even though we know temporally there's this big bang that begins our modern time that we exist in, it's potentially maybe time goes on forever in both directions beyond what we can see and what we can observe because of this big bang.
Yeah.
It's all these really cool ideas. I mean, you know, this Andy's talking about loop quantum gravity and string theory. These are two different ideas that people have of how time and space could be quantized and how we can reconcile this gravity with this quantum mechanics that we know works so well in these two separate areas.
Mhm,
It's just
mhm.
like this is really one of the big unanswered questions in research. And I think one of the things about quantum gravity specifically that makes it hard is that it's related to this analog computation we were talking about earlier, actually. Like gravity should, under Einstein's formulations, be able to tell you very precisely where a particle goes because of gravity. And you should need to know precisely where a particle goes in order to tell the motions of the rest of the particles.
Mhm.
But quantum mechanics tells us we can't know precisely where a particle is, at least without sacrificing lots of other information about it. In which case, how do you both know very precisely where a particle is and also not know precisely where a particle is. And so that's the hard part.
It really is. And
Well, this is the classic joke, right? Dr. Heisenberg gets pulled over by the cops and they say,
oh,
"Do you know how fast you were going?" And he says, "No, but I know where I am."
what a perfect way to end this episode. I think that pretty much says it all. We know,
Yep.
wherever you go, there you are. Buckaroo Banzai.
All right.
Across the 8th dimension.
All
Everybody,
right.
this has been so much fun. I really love it. Thank you, all of you who have brought in questions. Well, we are only able to answer a few of them today, but
Mhm.
we would love to answer more. Please put them all in anytime you want. And especially, we give our Patreons the first dibs in our episodes. So please feel free to participate in all of the ways that we're involved in producing this show and our privilege of answering your questions. And
Yeah.
a lot of all of this stuff is made possible because of Stacy Severin. Stacy, thank you so
Oh,
much for making this
thank you.
universe community possible and being part of this episode and so many, every single other episode, whether you're on or off the camera. And indirectly through you, I want to thank everyone on the team, the production team and the staff and the folks who make this show possible. Thank you, thank you, thank you, thank you.
Well, thank you so much. What a surprise to hear that. And, it is my delight and my privilege to be part of the LIUniverse with all of you and all the people who are not on camera today. So thank you.
Thank you so much, Stacy. Hannah Liu, our guest for today's Chuck GPT-4. Thank you so much for being here. Please come back often. We love hearing all the cool stuff that is not on the geeky science side, but is super geekily awesome nonetheless. Thank you, Hannah.
Oh, yeah. Very happy to be here and be a geek anytime. Thanks
Oh,
for having me.
my pleasure. And Alan Liu, our co-host, thank you as always for all that you do. Thank you, thank you, thank you, thank you.
Yeah, you're welcome. I'm always glad to be here every time, and it's always really fun.
And for all of you in the audience, thank you for being with us today. If you like what you've seen and heard, please support us on Patreon. And as always, thank you for being a part of the LIUniverse.